Welcome to Engineering Statics. In this video, I will introduce engineering mechanics, some fundamental concepts, two most common type of units, and finally I will discuss the problem-solving strategy. Engineering mechanics, or simply mechanics, is a branch of physical sciences that deals with the state of rest or motion of bodies under the action of forces. To know what happens to a thing, technically speaking a body, when subjected to forces. In general, this subject is subdivided into three branches: rigid body mechanics, deformable body mechanics, and fluid mechanics. In this course, we will study rigid body mechanics and statics, since it is the basic requirement for the study of mechanics of deformable bodies and fluids. Statics deals with the equilibrium of bodies that are either at rest or move with constant velocity, whereas dynamics is concerned with the accelerated bodies. This course is essential for the design and analysis of many types of structure members and mechanical and electrical components encountered in engineering problems. Let's first understand the meaning of certain fundamental concepts. There are four basic quantities which are used throughout engineering mechanics, such as length, time, mass, and force. Length is used to locate the position of a point in space and thereby describe the size of a physical system, such as to define distances and geometry of a body. Time is a succession of events. The principle of statics are time independent. However, this quantity has a significant role in the study of dynamics. Mass is a measure of quantity of matter that is manifested as a gravitational attraction between two bodies and provides a measure of the resistance of matter to a change in state. Force is considered as a push or pull exerted by one body on another. This interaction can occur when bodies are in contact, such as person pushing on a wall, or it can exist through a distance when the bodies are physically separated. In any case, a force is completely characterized by its magnitude, direction, and point of application. The second fundamental concept is the idealization, which is used in mechanics in order to simplify applications of the theory. Here we will consider three important concepts such as particle, rigid body, and concentrating force. A particle has a mass but neglected size. It can revolve around another object, but spinning about its axis is uncounted. For example, the size of the Earth is insignificant compared to the size of its orbit, and therefore the Earth can be modeled as a particle when studying its orbital motion. A rigid body can be considered as a combination of large number of particles in which all the particles remains at a fixed distance from one another before and after load exertion. It can rotate about its axis without any deformation. Concentrating force is considered when the area over which the load is applied is very small compared to the overall size of the body. It represents the effect of load at a point on a surface. An example is the contact force between a wheel and ground. Newton presented three laws of motion based on which the entire engineering mechanics is formulated from experimental observation. It may be noticed that these laws apply to the motion of a particle from a non-accelerating frame of reference. According to the first law, a particle originally at rest or move in a straight line with constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force. The second law takes it one step further and states that a particle acted upon by an unbalanced force experiences an acceleration that is the same direction as the resultant force and a magnitude that is directly proportional to the force. The third law is about the mutual forces of action and reaction between two particles that are equal, opposite, and collinear. The second most important contribution Newton did is the concept of gravity. Newton postulated a law of the gravitational attraction between any two particles. Mathematically, force is equal to a constant times the mass product of the two particles over square of the distance in between the two particles. G is the universal constant of gravitation, and according to experimental evidence, it is equal to 66.73 10 raised to the power minus 12 cubic meter per kg per square second. The final fundamental concept is the weight. It is the gravitational force exerted by the Earth on a particle near its surface. An approximate expression can be developed to find the weight of an object having a mass m. If we assume the Earth to be a non-rotating sphere of constant density and having mass m, and radius r is a distance between the Earth's center and the particle, then we can mathematically express W equal to mg, where g is the acceleration due to gravity. For most engineering calculation near the Earth's surface, g is taken as 9.81 meter per square second. There are two most common system of units used worldwide. One is the SI unit system and the other is the US customary system. The International System of Units, or SI units, is the modern version of metric system which has received worldwide recognitions for effective collaboration. In this system, the length is defined in meters, time in seconds, and mass in kilograms. The unit of force is called Newton, which is derived from the Newton's second law of motion. In the US customary system of units, length is measured in feet, time in seconds, and force in pounds. The unit of mass is slug, which is again derived from the Newton's second law of motion. The value of gravitational acceleration in this system is equal to 32.2 feet per square second near the Earth's surface. The most effective way of learning the principle of engineering mechanics is to solve problems. It is therefore important to always present the work in a logical and orderly manner as suggested by the following sequence of steps. Read the problem carefully and try to correlate the actual physical situations with the theory studied. Tabulate the problem data and draw any necessary diagrams. Apply the relevant principles, generally in mathematical form. When writing any equations, be sure they are dimensionally homogeneous. Solve the necessary equations and report the answers with no more than 3 significant figures. Study the answers with technical judgment and common sense to determine whether or not it seems plausible. This approach will not only save your time, but also minimize the chances of error.